This problem is more involved, so if you get to this type of problem on the written, I would skip over it and then come back to it after you've answered all the other questions and you have time to work on this one. So what they're asking for here is they're asking for the fuel difference between two different routes. So the original route that you have filed is this indicated by this blue line here, and for whatever reason, ATC, either for weather or other aircraft, or for some reason they have you vectoring around to a different route, this red route. And they're asking for what the difference in fuel would be for this new route that you've been assigned. So the first kind of quick, easy win we can get out of this one is we have to, we can basically ignore these first two legs for both routes. Because they're the same, it's going to come out in the end as a wash. So we can ignore this leg here. And so what we need to do is we need to determine the difference in fuel that's required from this VOR to this VOR between the blue and the red route. So in order to do that, we'll have to determine the ground speed for each route, and then using the ground speed, determine how much time we have between for each route, and then come up with the fuel that's required. So we're basically going to have two routes. We're going to have blue, blue 1, because there's only one segment in the blue, and then we're going to have red leg 1, red leg 2, and then red leg 3. So for each one of these, we're going to get heading information, distance, ground speed. That'll give us leg time, and then that'll get us fuel information. So heading for leg 1 is 351 degrees, and the distance given boxed in here between the two VORs is 75 nautical miles. And then for red leg 1, since we can skip this first portion, we're looking at 52 degrees and then 35 nautical miles. For the second leg, we're looking at 19 degrees and 33 nautical miles. And leg 3, 297 heading. And a total of 53 nautical miles. Alright, so going over to the E6B, this will be a heading and ground speed to start out with. So we'll start with the wind. Wind is 230 at 40 knots. Course is 351. And airspeed is 130 knots. That gives us a ground speed of 146. Then we can go into flight down to leg time. Distance 75 nautical miles. And then the ground speed carries forward from the related problem that we just worked. And that gives us a flight time of 30 minutes and 49 seconds. Then we can go into fuel. Same information carries forward, so we have the 30 minutes and 49 seconds. Then we're going to need to enter the gallons per hour, which is 17 given in the problem. So we'll burn through about 8.7 gallons in this leg of the blue route, our original route. So now we'll just need to work the same problem for routes 1, 2, and 3 of the red route. Legs 1, 2, 3 of the red route. So heading, enter wind information is going to stay the same. Course is 52 for the first leg. Airspeed stays the same. And then we get ground speed of 170. And as you get more familiar with working these problems, you won't have to write down the ground speed information because it'll carry forward. So now we're going to go into leg time. We've got our distance, we're going to change that to 35. Our ground speed carries forward 170, and we're going to get 12 minutes and 21 seconds. Alright, work the problem again for leg 2 of the red route. Wind stays the same. Course changes to 19. Airspeed the same. Ground speed is 162.6. Leg 3. Wind stays the same. Course is 297. Airspeed stays the same, and we have a ground speed of 109. Now we can go into flight, leg time. Distance is 33. Ground speed is 162.6. And that gives us 12:11. And we might as well go ahead and go for required fuel. 12:11, 17 gallons per hour, 3.5. Flight, down to leg time, distance 53 nautical miles, ground speed 109, 29 minutes and 10 seconds. Going to required fuel, time's good, 17 gallons per hour, 8.3. And we're going to go required fuel for the leg 1. Our time is going to be 12 minutes. So to enter minutes, we go 00 hours, 1, 2, minutes, and 11 seconds. Burning 17 gallons per hour. So 3.5. So total for the original route was 8.7, and then total for the new red route that we've been vectored is going to be 3.5 plus 3.5 plus 8.3 minus, or that's going to give us the total 16.6, and then the difference between the two is going to be 7. .6 minus 16.6 It's 15 point, should be 15.3. 15.3 minus 8.7 is 6.6 gallons difference. So the difference between the blue root and red root is going to be 6.6 gallons.